Working with WebSockets in iOS is not so complicated. Let's imagine we have WebSocket server and we have our app. In this app, we're gonna probably use URL session WebSocket task, and we're gonna use method.receive that provides data. So our WebSocket server will send data. It will send lots of data, and we need to process it. We're gonna have the data here. It will go into handle data. And let's imagine that this processing takes time. If we get the data, then we process it, then we call receive again. But we're only gonna call it after we process data. So if we have some messages here that we received while we're processing, we'll receive them later. So what we need to do, let's imagine this blue box represents a thread. What we need to do, we need to send it here somehow. But the best practice is to have a queue. So we need to add a queue here in the same thread. We're gonna add it to the queue, and immediately after we're gonna call to receive again. In that case, we're gonna receive data as fast as we can. What we do next, we need to handle the data from a queue. And then probably we'll have to update UUI. So we're gonna have one more thread that is gonna be main, where we're gonna update the UI. So that's best practice how you handle WebSockets connections in iOS. The question here is, what actually gonna happen if we're still gonna have our handle data that takes time here? Will we miss some of the messages, or will we process them but later? To figure this out, let's make a sample app. For a sample WebSocket server, I'm gonna use Swift Neo, so it's non-blocking IO server, and they have a sample WebSocket server. So if you scroll down to example usages, we're gonna have a simple WebSocket server, and it's just one file, server.swift. And I'm gonna use it. I already prepared this, but I just copy and pasted code here. So what it does, it creates both HTTP and WebSocket server. On HTTP, we just provide a sample page where you can see how it works. Only thing that I changed is I changed a package file. But I actually created the package file and provided all necessary dependencies. So it looks like this. And if you're gonna go and run Swift, we're gonna build, and then it will spin up a server for us. So let's see how it works. If you're gonna scroll to the main func, we're gonna see that it runs localhost 888 port. And we can see what it does. Client part is very simple, just receives data and immediately shows. And what server does, it sends new message every 100 milliseconds. Let's go and check. Yeah, here we can see that it sends data every 100 milliseconds and it's writes the frame, while frame is the time string. So we can add here something like var test, and we're gonna see, oh, we need to rerun, sure. Recompile. Yeah, now you can see that sends var test. I also created a sample Swift UI app. It creates URL session WebSocket task with our with URL of our sample server, and it's gonna receive the message. And receive message is very simple func. So what we have here, we just get the message and append that to our messages variable. The thing is here, that code is just for test purpose. So we are currently testing what's gonna happen if we gonna have a long processing. So this actually code you shouldn't have in production. We're testing how we should not do. Our content view is pretty simple. It's just messages. I'm gonna launch preview and see how it works. So what we can see now is that every 100 milliseconds we get the update. What I'm gonna do now, I'm gonna add a sleep here for 1 second to see how it's gonna work. What do we see here? That every second a value is added. However, the difference between these two values are 100 milliseconds. That actually means that we are processing these messages. So the message comes, we process it, then UI is updated, then new message comes, and it's still same message. So we are not dropping anything. And the question is, how does it work? Why are we not missing anything? To find this out, let's go to sources of foundation lib, and we need to find WebSocket task. And here in URL session WebSocket task, we need to find our receive func. So here's our receive function, and it has completion handler. So we can see that it uses work queue, and inside it append our completion handler to completion handlers and do pending work. So the do pending work, here we can see that if there is an if statement, so it's for error. So this one stated that we are interested in, and it goes through send buffer and receive buffer. So it takes first message, first handler, and send the message to a handler. And we open this receive buffer. So this receive buffer is the array of messages, and the only place where messages append is this append receive message function. If we open again do pending work function, we can see that it uses WebSocket URL protocol, and this code, in the code of this class, it actually append receive messages here. So it's for binary or for text message. For both of these cases, it appends message. So that means that URL WebSocket session already has a buffer with messages. So that means if there is a new message received while we are still processing data, a new message will go here in the buffer. But still the best practice is to handle this on your side, to have a queue, then process data in a separate thread, and if needed, then update in UI. And if you need to update UI, it should be done in the main thread. So basically what we need to do, we need to get the data from URL WebSocket sessions as fast as we can, keep that here, and then process it. That's it.